In my experience, a floating island isn't really a floating island unless there's something on that floating island trying to knock you off of it. In this prototype, that means enemy spheres with one goal and one goal only: to see the player go over the edge, even if it means throwing themselves off too. Well, by the end of this lesson, an enemy will spawn on the floating island and then follow the player around trying to knock them off. Up to this point, when we've used vectors, we've always used a particular preset direction. Vector 3 dot up, down, left, right, forward, back. The tricky thing about getting the enemy to follow the player, though, is that the direction will always change as the player moves around. So we can't use any of those preset directions. To be able to pull this off, we have to get a better understanding of what a vector really is. A vector is a distance and direction in 3D space. So if this is the enemy's position, and this is the player's position, this vector describes the distance and direction between them, which also happens to be the direction we want the enemy to move in. But how do we calculate that vector? How do we get it and use it for the enemy direction? Well, you know how generally, if you can add A plus B to equal C, you can also subtract C minus A to get B? It'd be like if 1 plus 2 equals 3, then you know that 3 minus 1 equals 2. Don't worry, I'm going somewhere with this, because the same is true of our vectors. Since the enemy position plus that vector equals the player's position, you can also subtract the player's position minus the enemy's position to get that vector. And that's exactly what we'll do. We'll take the player position, subtract the enemy position, and that will give us the vector, or distance and direction the enemy should move in. And to make all that happen, I'll see you in Unity. Great, so we have our player movement set up pretty well. And you can see when we move the player around, we can move it all around this platform. So now what we're going to do is we're going to introduce more difficulty into this little game by adding in enemies. If we right-click on the hierarchy, create a 3D object, and we'll make another sphere. So you can see here our sphere has actually gone underneath the platform, so we'll bring that up just a little bit. And to make things easier, we'll bring it up in front of the player. And then we're going to just make this as large as the player. Just so we can differentiate, we're going to just take one of our other textures and apply it onto the enemy sphere. So that looks pretty good. We'll rename this to be an enemy. And then we're just going to bring this closer to the ground. So let's make this just at 0. And then we'll bring this down to maybe 0.15. And then we'll just make this an even 6. Now we're going to add a rigid body to this enemy, so then that way both the player and the enemy can interact through physics. So if we go to add component, type rigid, we have a rigid body. Cool. So now when we press play, you should be able to see the player runs into the enemy ball, and it creates this little, bumps it off a little bit. So what we're actually going to do is we're going to augment the physics in small ways. So we're actually going to go into our assets folder, right-click on assets. We're going to create a new folder, and we're going to call this physics material. Now, in our physics materials folder is where we're actually going to keep all of the different physics materials that we might be creating for our different objects in our scene. If we right-click on Physics Materials, we're going to create a physics material, at the bottom, and we're going to name this material Bouncy. So if we left-click and drag Bouncy onto our player, and we left-click and drag Bouncy onto our enemy, we'll see if any effect happens. So you notice several things. One, the friction is actually making a huge difference now. So on our physics material, we can actually apply even more physics properties. On our player, rigid bodies can store things like mass and drag and gravity. But on physics materials, we can actually change the friction of how much friction there is when something is standing still versus dynamic friction, which is when it's moving, how much friction is applied. Or we can change the bounciness, so how bouncy something will be when it runs into something else. So since this is 0, there's not going to be a very large bounce effect, so we'll set this to 1. And then one of the other things that we're going to do is under this bounce combine option, there are different options that you can select. So we can select the minimum amount of bounce that would happen when two things collide. We can create the maximum amount of bounce that would happen when those two things collide, taking the larger value of that one or that one. We can average it, so then it would actually cut those values in half. Or we can multiply it, so it'll increase the value. So the bounciness of this material and the bounciness of this material will actually be amplified. So we'll make it multiply for now, and then we'll press play and we'll see. We still have a bit of friction, but the bounce is definitely a lot more significant now, which is really good. Now, in order to check just to make sure that you have your bouncy physics materials on each of your objects, if you go to player, under the colliders, there's actually a spot for the material, and that's where the materials are applied. So if we do the same thing for the enemy, you check their sphere collider, and you can see under material, there's a bouncy physics material applied. So now it's your turn. You're going to create your own enemy. Make sure you apply a new texture to it, scale it up, position it in your scene, make sure you rename it as enemy in your hierarchy. Then you're going to go into your assets folder, create a new physics material folder. In that folder, you're going to create a physics material called Bouncy. On Bouncy, you're going to change the bounciness value to 1 and change Bouncy combine to multiply. And then you're going to click and drag Bouncy onto your player and your enemy so they both have that physics material applied. And then you can test and see how bouncy it is when your player runs into another object. Now it's your turn. So we've added these physics materials to our player and our enemy, so that way when they collide, creates this bouncy bump. Now, so we've added these physics materials to our player and our enemy, so that way when they collide, creates this bouncy bump. Now, we need to make it so that the enemy can actually chase the player around the scene. So, we're going to use a script to do that. In our project window, we're going to go into our scripts folder. We're going to right-click and create a new C# script. And for this, we'll just call it enemy. So this will hold all the behaviors that the enemy should manage. And we're going to make sure we click and drag the enemy script onto the enemy. And you can see it's been applied. So now we're going to go into our enemy script by opening it up. Now, in our enemy script, let's think about some of the things that we want to do. So we're going to need a speed to be able to make the enemy move. So we'll make this another public so we can fix it in the editor. Float speed, and we'll set this to, we'll set it to a little slower, so make it 3 for now. Another thing we need to do is, because we're going to try and move this object, we need the rigid body component. So we need a private rigid body. And we'll just call this enemy RB. And now we need to actually get the reference of that rigid body on the object. So we use our enemy RB variable. And we set that to the component of our rigid body on our enemy. Now, we need to move this enemy. To actually visualize what we're trying to do here, we're trying to move the enemy from their position to our player's position. Now, if we think about it in terms of how we apply the force, since we're trying to move our enemy towards the player, we should take our player's current position, and then we need to subtract it from our enemy's position. So in fact, we actually need a reference to our player. Since we know how to find our player, we'll make this a private variable, and this will just be the game object, and we'll just call it the player. In our start method, we need to find that actual player, so we'll use our player variable, and we set that to the game object in our scene. We find it by its name, which in this case we named it player. So now we have the reference to our player. And so now we need to apply a force in the direction of our player. So we need our rigid body again. And we add a force. And how we're going to add this force is we're going to take our player's position. So we need to use player. And we get their transform to get their current position. And we're going to subtract by our enemy's current position. So we need our transform here. And we need the position. So now we know the direction that we're trying to go by subtracting our player's position from the current enemy position. So that will give us the vector 3 coordinates that we need to go towards at all times. In this case, we're going to apply our speed. So that way we know how fast the enemy should be moving. One thing to consider is, because this is actually a math equation, so our computer will read this as a math equation, it will actually follow standard rules. So, because transform.position is being multiplied by speed, it'll actually do that first before it subtracts from the position. So that's not what we want to happen. We want to get the direction that we're trying to go to before we apply the speed. So we use parentheses, so then that way make sure that first we're going to subtract the player's position and our current position, and then we're going to multiply that vector 3 by a certain speed. Now let's make sure we save. And then in Unity, if we play our game, we should see the enemy is very aggressively rolling towards us. So that's good. Now, one of the things that you might see is it was going very fast. Now, the reason that happens is because as the player gets farther away from the enemy, the length of that actual vector, the distance between those two positions becomes larger. And so what it actually does is it tries to multiply it over a very large amount of distance, so it actually increases in force over time. We can actually use some code to prevent that from happening. So what we're going to do is we're going to actually create a standard strength, so that way, even if the enemy is really far away from the player, it doesn't actually get an increased magnitude, an increased strength of its force over time because the distance is larger. We can use a dot normalized after this vector 3. So this will actually normalize the magnitude of this vector. So it doesn't matter how close or how far the enemy is from the player, it will always be coming at the same speed. So if we save, so now in Unity, when we press play, we should see that the enemy doesn't move at a very fast speed and doesn't accelerate really quickly when it runs into the player, which is exactly what we want. So now it's your turn. You're going to go into your assets folder in your scripts and make an enemy script. Make sure you apply that enemy script to your enemy as a component. In your editor, you're going to create 3 new variables. So we're going to get a speed variable. We're going to get the rigid body. We're going to get a reference to the player. In our start method, make sure that you get the component for that rigid body and make sure that you find that player in the game hierarchy. And then in our update method, you're going to add a force to the enemy's rigid body, and you're going to get the player's position, subtract our current position so that we get a direction we're trying to go to. Make sure that you put both of those in parentheses so that way it does that operation first. You're going to dot normalized so that way we can actually normalize that vector so it doesn't accelerate at a very fast speed the farther the two objects are away. And then we're going to multiply by the speed that we set. Now it's your turn. So we're really rolling now. We've got our enemy that rolls towards our player, and it's not moving at an incredibly fast speed. So one real quick thing that we're going to do is we're just going to clean up some of our code. So in our update function, we have this really long line of code here. So we're actually just going to clean this up a little bit by using one variable. Now, because in our update function is the only place that we're really going to be calculating the position of the player against the current position of the enemy, this is where we're going to create our variable so that we don't need it anywhere else. So we're going to create a vector 3 because we're taking in two different positions, our player and our current transform. We'll call this vector 3 the look direction. So this will actually be the direction that the enemy will be moving towards. We're going to set this, and we're actually just going to take this line of code. We can cut it and paste it, and then we'll close off with the semicolon. Now, the reason why we keep our equation here still in parentheses is just so that we can use the .normalized. So that way we can apply our normalized vector onto the final vector that comes out of this position here. So now that we have that in our add force, we can just put look direction. And when we save, if we test our game, you can see that the enemy is still moving at the same speed towards the player. So now it's your turn. In your update, is going to move, and then it doesn't increase. And then your look direction, you'll just add into your add force. Now it's your turn. Our enemy is now set up exactly the way that we want it to. So now what we're going to do is we're actually going to create a prefab of our enemy so that we can use it over and over again, and we'll actually manage all of these enemies through a spawn manager. So in our assets folder, if you right click, we'll create a new folder, and we'll call it prefabs, where we'll keep all of our prefabs. We'll take our enemy in our hierarchy and we'll drag and drop it into our prefabs. And in this case, our enemy basically has all the different components that we need. I don't think we're going to change it anymore, so we can actually just right click and delete it from our project hierarchy. Now what we're going to do is create a new spawn manager in our hierarchy. So we right click, we're going to create an empty object, and then we're going to rename our game object to be spawn manager. We don't really need to reset its position or anything like that, just because it's just going to take in numbers from our screen anyways. In our assets folder, we're going to go into our scripts and create a new C# script for our spawn manager. Make sure you drag and drop that onto the spawn manager object. And now if we open our spawn manager script, now we're going to need a reference to our enemy prefabs. So we'll create a public game object. That way we can drag and drop it from our prefabs folder into our editor. And we'll call it enemy prefab. And then in our start method, we're just going to spawn our enemy in a random location. So since we have a prefab, we need to use our instantiate method so that we can create another instance or a clone of our enemy prefab.
We're going to need our enemy prefab to actually create. For now, we'll just spawn this enemy in a random coordinate. So we'll just make a new vector 3. And we'll just put it at 0, 0, 6. And last but not least, we're going to position our prefab in the right orientation. So we're going to use our enemy prefab, get its transform, and then just make sure it's oriented right. So we're going to use the rotation we set in the prefab. So now when we save, in Unity, we should magically see an enemy pop up somewhere on this platform. And there's no enemy. Well, if we look at the bottom of Unity, you can see that we have an error. In fact, you can actually click on these errors, and it will open up our console window. So whenever we see these errors or these warnings, they usually pop up in the console, and then we can actually take our console. If we click on the little tab, we can drag it into other places. So in this case, I'll put it next to my scene. So now we can actually see any error messages that pop up when we play the game. So the prefab has not been assigned. Okay. So we can clear that, I think. So on our spawn manager, yes. So we didn't drop our enemy prefab into the variable. So let's just make sure we drop that in so there's a reference to that. So now that our enemy prefab has a reference to our actual prefab, when we press play, should see our enemy pops up, and then they bounce, and then we'll see if we can escape. I'm too fast. And then we both fall. So what you're going to do is in your assets folder, make sure you create a prefabs folder. Take your enemy game object, drag it into that prefabs folder so we can create our own prefab. You can then delete the enemy from the scene because I don't think we'll need to change it. Then you're going to right click in the project hierarchy. You're going to create an empty object, rename that empty object to be a spawn manager. In your scripts folder, create a spawn manager script. Make sure you add it as a component onto the spawn manager. And then in your spawn manager script, you're going to make sure you create a reference to your enemy prefab. And then we're going to instantiate that enemy prefab in our start method. And we're just going to put it at a random position for now and make sure that it's rotated in the right direction. And then just make sure that you drag the enemy prefab into the enemy prefab slot on the script, so that way there's a reference to it, and then test your game out. Now it's your turn. So we're able to spawn our enemy using code now, and we can set it to whatever positions that we want, but we're going to make it a little bit more random than just manually putting in a position to spawn at. So we're actually going to use the random class again to generate random numbers that the enemies will spawn at. So in our start method is where we're going to create these random positions. So we'll use a float, and we need a spawn position. Now, keep in mind, in our game, we have a certain range that we want to work in for the X and the Z. So on the Z, if we just use our spawn manager, for example, so probably about up to there or so, so around like 9 on the Z, so -9 or so on the other side. And then on the X, so we want to make sure that it's even. So we could probably keep it -9 and 9 as well. So for our spawn position, we'll both need an X in case we want to change the range at all. And we'll make it be a random range. And the minimum value that we want is going to be -9. And we're going to use a maximum value of 9. And then same thing for our Z position. So a float spawn position of Z. Get a random range. And we'll say -9 and 9 for that for now. And then in our instantiate method, so we can change this new vector3. We'll make it a spawn position X and a spawn position Z. Now, if we wanted to clean this up even just a little bit more, so we can make like a new vector3. We'll make this the actual random position. And then we can actually just take out this entire line, and we'll paste it. And then where that new vector3 was, we can just call this random position. So now this line is very readable. We're instantiating our enemy prefab at a random position using the rotation that it's set at, and then we calculate that random position above it. Last but not least, now we do have a few more hard-coded values, so we'll clean that up just a little bit more just to make our code as readable as possible. So we're going to make a private variable this time of float, and we'll call this the spawn range, and we'll make that 9. So then that way, we're always keeping it within that square, so that way we don't accidentally spawn an enemy outside of the octagon shape that we have. We'll go into our random range, just change this to spawn range. One thing to note, this is a bit redundant. We could easily just make it a spawn position, but if we ever wanted to change the Z, at least now we have the option, so it just makes things a little bit easier. So now when we save and we go into Unity, when we play our game, you should see a ball spawns in a random position, and then we stop. If we try again, different position, and then one more time for good measure. And there you go. Awesome. So what you're going to do is in your spawn manager class, you can create your own private float variable for the spawn range. In our start class, we're just going to clean up our code a lot and make it so that our enemies spawn at a random position. So using a X position variable for the spawn, we'll set it to a random range within our spawn range between the negative and the positive position. Same thing with the Z, to a negative and positive position somewhere within a random range. We're going to create a new vector3 to hold our position. And that's where we're going to change out the hard-coded values to be our spawn position for the X and the Z. And then in our instantiate method, we can just take out that entire vector3 and then just make that one whole variable So then this line of code is incredibly easy to read. Now it's your turn. We've added the ability for our enemy to spawn at random positions on our screen. Now we're going to do just a bit more code cleanup and teach you something new about creating your own custom methods. Now in the past, we've made our own custom functions before, so we're going to do that again. About creating your own, in our start method, a way to create a position for each of our enemies. Now in the past, we've made our own custom functions before, so we're going to do that again. Now, we're going to make this a private method, so that way we only need to use this method inside of this class, so we don't need it anywhere else really. For now, we're going to make this a void method, so it doesn't really do anything except tell us things. We're going to call it generate spawn position, and then we can just leave the parentheses because we're not actually passing it any information. It's just going to do something. So now in our generate spawn position, anything with the coordinate. Now this is a key difference we use for specific tasks. So void does this calculation, gives us a random coordinate, and then it doesn't actually do anything with the coordinate. Now this is a key difference between using void functions and return type functions. So a void function you use for specific tasks that you do not need to return a value. For example, in one of our previous lessons, we actually used a spawn method using the void keyword. Now, in that case, we just wanted to create a random object on the screen, and that's all that method did. However, when we actually use methods that return a value, we do it for the purpose of giving us information after a calculation. So, generate spawn position actually gives us a position that we need to use. So, we take out the void keyword and we put in the specific type of data that we want to come out of this method. In this case, we go from a void to a vector3. Now you can see that our program is mad at us because this doesn't return a value. Fortunately, we have a value here. We have a vector3 that we've already made, but now we need this vector3 to actually come out and result from this method. So if we actually type in the keyword return, start method, it's no longer unhappy with us. That's because in place of our random position, it's a very to actually get that data back from that method. Difference between vector3s and voids, but over time as you use them. So what you're going to do, right, random positions on the x and the z. We then take our